Okay, we had a special request to make a video about how one might model a power line in OU and PPM. And so it turns out that we just got back from doing a training in Bangkok, and they had noticed an issue with VOR wires, and so that has been fixed as of version 1998C. So if you want to model VOR wires, I would recommend using version 1998C or higher. Otherwise, the VOR wires may not follow the standard VOR conventions. And so we want to do a VOR model, so we're going to go to New Model VOR, and then I'm going to do a scenario with two poles and a power line. And so the first thing we're going to do is we're going to create the poles. And so the poles are basically vertical cylinders, right? So a great way to do that is probably using our ellipse preset. And so in the US, a telephone pole has a radius of around 15 inches, which is 1¼ feet. So I'm going to use that for our axis A and axis B. And they're typically about 40 feet tall. And I'm going to make sure I illuminate the outside. And this should create a... I'm going to do that again because I want to use more than 3 segments. So I'm going to come in here, 1.25, 1.25. I'm going to say 10 segments for a circle, illuminate the outside, and we're going to make it a 40-foot tall pole. And so just to look at it in the editor, I can see that looks sort of like a telephone pole to me. And so now, obviously, we have to ask ourselves, do we want to keep this at the origin or do we want to position it somewhere? Since I've got more than one of them, I'm going to keep it at the origin so that I can make sure it's put in the same place. Now, I'm going to save this as telephone pole.psc. And so now I've got a telephone pole model. So I'm going to come back to our world, and I'm going to add the telephone pole, and I'm going to add 2 of them. Okay, and so we're going to go ahead and use our range bearing entry method since we're doing a VOR. And just to make things easy, I'm going to say they're 500 feet away from the VOR. This one's at a bearing of 40, and this one's at a bearing of 50. So let's look at our virtual world here. So it's between our north axis and our east axis, 40 and 50 degrees rotated from the from north. And so that's where our 2 poles are going to be. Now, what are we going to do about the wire? So you'll notice, in our 3-day training, we don't actually talk about wires very much, but we're gonna make a wire here. So there is a special rule that says that for wires, we don't recommend that the diameter of the wire be more than 1/10 of a wavelength. If it is more than 1/10 of a wavelength, then you probably should start thinking about using plates instead. So if it's like a bundle of wires, maybe use a plate. So I probably shouldn't make the default for this 1 foot. I'm going to say 0.1 foot. And so I know I put the poles at the origin. We don't really have a good way to do that for wires. So I'm going to go ahead and do our range bearing. Now this is slightly different. For the plates, we give the range and the bearing to the center of the plate. We're actually going to do it for both endpoints for wires. So again, I'm going to say the range is 500. The bearing is 40. Since the pole is 40 feet tall, we're going to say the height of this is going to be 39. I'm going to do another 500 and 50 and another 39. And we're assuming that the ground elevation is the same as the VOR. So now we've got a wire here that is between 40 and bearing of 40 and a bearing of 50. So we're going to go ahead and save this as, I'm just going to call it wire 1. You'll notice that the wire scatters have a separate, different extension than the plate scatters. And so when I add this to the world, it should be in the right spot because I didn't position it relative to origin. So we're actually probably going to basically have zero values in the table. We're going to come in here and call this wire 1. Now we've got a wire in here. And you'll see I'm leaving these values alone. And so that should probably actually be a 0. But I think if you don't touch it, it'll be okay. Because you'll see that the wire is in the right spot relative to these poles. And so now I've got my VOR scenario with 2 poles and this wire, and we're going to assume you're probably using a Doppler VOR if you're outside the United States. And just to make things, slightly more fidelity, we're going to use the physical Alford loop model, although that's going to take a while to run. So I'm going to start the run. And it's going to give you a warning that some of the scatters are smaller than a NAVAID wavelength. That's because the poles aren't very big. So the results you see are probably going to be slightly higher than what you'd actually measure, which is safer, right? Now, obviously, if it puts you slightly out of tolerance, then you're going to have a decision to make. But I'm going to say this is good enough for now. So this is going to take a little while to run, so I'm going to pause the video and then come back once the results are there. Okay, so we've got our results. If you haven't used VOR in a while, you'll notice that the roughness filter shows up by default. This is an orbit. We got a special request from the FAA not to do the bend filters by default for the orbits. They also, their results seem to mirror these things, so they aren't on top of each other. But this is what the result would look like. The gray lines are the tolerance bounds. So you can see this this wire by itself and these poles would not put it outside of tolerance. In fact, if we want to see a little bit more detail on exactly how much they're using, we can come in here and say on the range axis, let's do increments of maybe 0.5 degrees. And now you can see that these use less than plus or minus 1 degree of error by themselves. And you'll notice that the wires, this is placed on sort of the 40 to 50 degree arc. And so you get a spike around that part. That is probably the diffraction off the wire itself. Whereas on the 180 degrees off of this, on the other side, where the plane's flying over here, you're going to see maybe not quite as extreme error, but a much wider range of things. So that is an example of creating a telephone line or any sort of power line in OUN PPM. Now, obviously, some power lines, sag a little bit. We don't model something like that, but hopefully these results will get you close enough. Thanks.